Understanding neural networks and deep learning, a simple guide. In our increasingly digital world, artificial intelligence has become integral to various technologies we use every day. One key component of AI is a branch called deep learning, which relies on neural networks. Even if you're not a scientist, you can grasp the fundamentals of these concepts. Let's break them down into simple, detailed terms. What is a neural network? As its core, a neural network is a computer system designed to stimulate how the human brain works. Just like the brain processes information through neurons, a neural network processes data through artificial neurons. Components of a neural network. Neurons. There are basic units of neural network. Each artificial neuron receives input, processes it, and produces output. Think of each neuron as a tiny decision maker. Layers. Neurons are arranged in layers. Input layer. This is where the neural network receives data. For instance, if you are teaching a network to recognize cats, the input layer will receive images of cats. Hidden layers. These are layers between the input and output layers. They do the heavy lifting, analyzing the data further. Your network can have multiple hidden layers. Output layer. This is the final layer that produces the result. In our cat example, it will indicate whether the image is of a cat or not. Weights and biases. Each connection between the neurons has an associated weight which adjusts the importance of the input. Bias helps shift the activation function to better fit the data. Essentially, weights and biases are what the network learns during training. How does a neural network work? Neural network works by performing calculations and adjustments based on provided data. This is a simplified version of their operation. Data input. The input data, say images, is fed into the neural network. Forward propagation. The data travels through network's layer. Each neuron applies a linear transformation and an activation function to decide how to process the input. Loss calculation. After the data has passed through all layers, the network produces an output. We then calculate how far off the network's output is from the actual result. A result called the loss. Backpropagation. To improve accuracy, the network adjusts its weight and biases based on the loss. It works backward from the output layer to the input layer, refining the connection and learning from its mistakes. Iteration. The process is repeated numerous times using many data examples. Over time, the network becomes better at making predictions or classifications. So what is deep learning? Deep learning is a specific type of neural network that uses many hidden layers, hence the term deep. The primary advantage of deep learning is its ability to learn complex patterns in large volumes of data. Here are some simple aspects of deep learning. Multiple layers. While a standard neural network might have one or two hidden layers, deep learning networks typically have several, allowing them to recognize intricate patterns, like distinguishing between a dog and cat, or even human emotions from facial expressions. Feature extraction. Deep learning networks can automatically identify the features that are important for decision making. For example, in image recognition, lower layers might detect edges, while higher layers recognize shapes and then finally distinguish whole objects. Data requirements. Deep learning models often require extensive data sets to train effectively. They thrive on a huge amount of data to achieve high performance. Real-world applications of neural networks and deep learning. Neural networks and deep learning are behind many technologies you might be familiar with, such as voice assistants. A service like Siri or Alexa use deep learning to understand spoken commands and respond appropriately. Image recognition. Social media platforms automatically tag your friends in photos using deep learning algorithms. Self-driving cars. Autonomous vehicles use neural networks to analyze their surroundings and make safe driving decisions. Recommendation systems. Streaming services and online shopping sites recommend movies or products based on your preference using deep learning models. So, concluding everything, neural networks and deep learning might sound complex at first, but they are essentially sophisticated tools inspired by the human brain, designed to recognize patterns and make decisions. As you explore this topic further, remember that these technologies are transforming industries, creating efficiencies and capabilities we never thought possible. Whether you're an aspiring AI enthusiast or just curious, understanding these concepts is a valuable step towards grasping the future of technology.